Hello, my bomb blowers and modular masters, and today I am here with another Keep Talking and Nobody Explodes modded module tutorial, and today I am here with the module Quick Arithmetic. Quick Arithmetic got a complete rework, and the module is considerably more difficult from its previous version, which was just doing some basic math with two 8-digit numbers, but now you've got two number sequences, you gotta modify the sequences, you gotta sum the sequences, you gotta do a lot. Let's go ahead and get started. This module does not require any edgework, so as soon as we get our bomb, we can get started.
There is only one perfect solution, but there are
a quick arithmetic module has a display of cycling digits. Between any two modules, one will be cycling slower, which is the left one on this one, and one will be cycling faster, which is the right on this one. And you can see on this one, the left is cycling faster than the right. And you can see on this one, the left has the color sequence, the right has the color sequence here. You get the picture. So there are three sequences being displayed right now. The color sequence, the primary sequence, and the secondary sequence. The color sequence is, as you may imagine, the 8 colors that the 8 numbers on the right are. So let's go ahead and write those down. Red, cyan, pink, cyan, cyan, yellow, blue, pink. The primary sequence are the numerical digits that are colored. So those are going to be the digits on the right for this module. Let's get them down. 8, 5, 8, 7, 1, 7, 5, 0. And then the secondary sequence is the sequence of digits that is in a white, pure white. So now let's go ahead and get these down. 6, 4, 3, 1, 3, 7, 9, 2. So, we're going to modify the two sequences, the primary and the secondary sequence, based on the color sequence. So we're going to apply the modification of the red rule, then the cyan rule, then the pink rule, then the cyan rule twice, then yellow, then blue, then the pink. So let's go ahead and get through these. So for red, we add the current digit in the secondary sequence to the current digit in the primary sequence. Whenever you get an operation, like these top four all require you to do an operation. So what you do with the result, for example, red here is 8 plus 6. 8 plus 6 is 14, so we're going to replace the digit in the primary sequence of the position that we just modified, because red is first and we're looking at the first two numbers. We're going to replace the digit in the primary sequence with a result, which is 14. We're not going to modulo 10. Please note that down. This is not a modulo 10. 8 plus 6 is 14, so we are taking 14. So we've done our red condition, let's go to cyan. Swap the current digits and reverse secondary sequence. So the current digits are the ones under the cyan we're working with. So we're going to swap the digits, and now we're reversing the secondary sequence. 2, 9, 7, 3, 1, 3, 5, 6. Now that we're done with that, let's go to the pink condition. Stuck with the primary sequence's digits left once. So we're going to take the primary sequence, take the last number out from the end, and put it at the front. That's what cycling left means. Now we're going to do the cyan condition twice. Swap the current digits and reverse the secondary sequence. Alright, so first off, this one, we swap 3 and 1, and we reverse secondary sequence. 6, 5, 3, 1, 1, 7, 9, 2. Then, for the second cyan, we swap these two, 1 to 7, and then we reverse the secondary sequence. 2, 9, 7, 7, 1, 3, 5, 6. Now we move on to the yellow. Divide the current digit in the primary by the current digit in the secondary sequence, rounding to the nearest integer if necessary. If you have to divide by 0, ignore this step. So, let's get the calculator out for this one. 5 divided by 3 is 1.6 repeating. That rounds up to the nearest integer, so we're going to replace the primary sequence digit with a 2, because that's the result of the primary divided by the secondary. Next, we take the blue condition. Subtract the current digit in the secondary from the current digit in the primary. So we have 0 minus 5, this is negative 5. we keep the negative sign, like we kept both digits of the 14. And then finally we have the pink condition, stuck with the primary sequence digits left once. And now we have our final two sequences. We can get rid of the color sequence now, we couldn't care less about it. So what we're going to do now is we're going to sum the digits at the positions. So the first positions in the primary and secondary are 8 and 2, 8 plus 2 is 10. Then we're going to take the second digits, 9 and 7, 9 plus 7 is 16. Then we sum the third digits, 7 plus 3 is 10, 7 plus 1 is 8, 2 plus 1 is 3. Negative 5 plus 3 is negative 2, but we take the absolute value. So we get 2. 14 plus 5 is 19. 4 plus 6 is 10. Now, in order, we're going to look these numbers up in this table. So our first number is 10, which gives us 89. We're going to set the display here to 89 and submit it using the center button. So the top left button cycles the left digit up once, the bottom left cycles it down once, and the same thing happens with the right button. So we enter 89, and it was good. Next, we input 16. 1 and 6 gives us 56. That was good. Now we're entering 10 again, which is 8, 9. That was good. Then we enter 8. 0, 8 gives us 0, 8. Now we're entering 3, which is 8, 6. Now we enter 2, which is 9, 4. Now we're entering 19, which is 0, 1. And finally, we're entering 10, which is 1, 0, which is 8, 9. And that is a solved module. Let's do this one more time. We have the color sequence, the primary sequence, and the secondary sequence. First, let's get our colors. Black, white, yellow, brown, purple, cyan, red, green. Got lots of different ones this time. In fact, I don't think we even repeated any, so this should be a good one to practice with. Then we get the primary sequence, 2, 9, 8, 2, 0, 7, 6, 5. Primary sequence is the one that's colored, the secondary sequence is the one that's white. And then the secondary sequence, we have 7, 6, 3, 1, 9, 0, 4, 1. And now we do our modifications. The black modification is to cycle the secondary sequence left once. So we take the last digit and stick it at the front. Next we take the white. Cycle the secondary sequence right once. Well, let's just undo what we just did. Take the last digit, put it at the front. Yellow. It's the division rule, so we are going to take 8 divided by 3. Gives us 2.6 repeating, that rounds up to 3. So we're going to replace the primary sequence digit with a 3. Next we have brown. Swap the current digits and reverse the primary sequence. So we swap the two digits in this spot, 1 and 2, and we're reversing the primary sequence, 5, 6, 7, 0, 1, 3, 9, 2. Then we have purple. Subtract the current primary digit from 9. Okay, so 9 minus 1 is 8, and now we're replacing the primary sequence digit with the result. Next we have cyan. Swap the current digits and reverse secondary. Alright, we have 0 and 3, and we're reversing secondary. 1, 4, 3, 9, 2, 3, 6, 7. Next we have red. Add the two digits. 9 plus 6 is 15, so we're going to replace the primary with 15. And then finally, green. Multiply the current digit in the primary by the current digit in the secondary, and take the last digit. This is a modulo 10. So 2 times 7 is 14, but we take the last digit, so it's actually 4. So we have done all of our modifications, we can get rid of the color sequence, and now we take the sum of all of the digits at the spots in the sequence. So 5 and 1 is 6, 6 and 4 is 10, 7 and 3 is 10, 0, 9 is 9, 8, 2 is 10, 3, 0 is 3, 15, 6 is 21, and 7, 4 is 11. Next we take the numbers, look them up in the table, and submit those numbers to the module. We have 0, 6, which gives us 8, 7. Then 10, which gives us 8, 9. Twice. Then 9. 0, 9 is 6, 7. Then 10 again, which is 8, 9. Then a 3, which is 8, 6. Then a 21, which is 4, 6. And then finally 11, which is 4, 2. If you strike, then any integers that you have inputted that are correct will stay inputted. This is not going to reset on a strike, but you just have to input the rest of the correct sequence. That is it for this tutorial. Thank you for watching, and have a nice day.